off by a few thousand, but actually it was Makes sense to you though? You could use the net present value formula. It takes a long time to go around the barn. You could use the present value of, I'm sorry, it's a big barn. All right. Okay, I use those analogies. So anyway, you could use the present value of the annuity, figure out what the annuity of these payments are, but just make sure you subtract your initial expenditure of on that from those numbers, from that present value. You can do that every time was the question. If it's an annuity, you can. But what happens is a lot of times when we look at other present value formulas, they're saying, okay, the first year we're going to save $2,500. The second year it's going to be $5,000. The third year it's $3,000. That's not an annuity because the payments aren't the same. But if you have anything where you have the same payment over multiple years, that's an annuity. So you can figure out what the present value of the annuity is. Just make sure you subtract the initial investment to give you your net present value here. Mm-hmm. Sure. Exactly. Yep. One of the statements that were made was that sometimes not only will the payments vary, but the interest rates will vary each year. So you would have to use the net present value formula. You couldn't use the annuity formula. That's a very good point. Okay. So there you go. A couple of 12 assignments to go over those 85 questions that you're going to be asked on the exam. There may be 2 or 3 questions from this chapter that'll involve you using calculations on the exam. Okay, so don't spend hours and hours trying to figure this out to the T to the expense of learning the other material. So just, try to be balanced in your studying approach to the exam. Okay, question 5. James wants to buy a house in 5 years, and he estimates that he will need to accumulate $60,000 for a down payment over the next 5 years. If a savings account pays 8% compounded interest annually, how much should he deposit at the end of each of the next 5 years? Okay, this is an annuity because he wants to put a certain amount aside every year, and you're trying to solve for what that amount is. Okay, it's an annuity. You know the future value of the annuity, which is $60,000. You're trying to calculate the payments that you need to put aside to make that. So that's why this is an annuity. So again, in your head, you need to have these key thoughts. Anything where you get the same payment or make the same payment over multiple years, that's an annuity. Anytime we're saying what the payment will be in the future or what the amount will be, that's a future value. So I know my future value. I know it's an annuity. So I need to use my future value of an annuity formula and solve for A, the amount. So here's the formula. And basically I plugged it in. 60,000 equals A times 1.8 to the 5th minus 1 divided by 0.08. And when I flip that equation around to solve for A, so your algebra comes into play, that's $60,000 divided by the other half of that formula, which is $60,000 divided by 5.86. So that tells us we need to pay $10.23891 a year. I have to put those aside for the next, is it 5 years? Yeah, 5 years to come to $60,000. And again, notice the rounding difference, okay? I got $103891. The answer is $10,227. So